Assalamualaikum everyone, my name is Alvyna Khairunisa. I'm from D class. My student ID is 206-13038. Today I will show you an experiment of surface tension and interface tension. Please keep watching. Surface tension is the tendency of liquid surfaces to shrink into the minimum surface area possible. Surface tension allows insects to float and slide on a water surface without becoming submerged. Interfacial tension is the force of the attraction between the molecules at the interface of two fluids. At the air-liquid interface, this force is often referred to as surface tension. Surfactants are amphiphilic molecules. Their heads are polar or hydrophilic, and their tails are hydrophobic or nonpolar. They are soluble in both organic solvents and water. The surfactant reduces the surface tension of water by absorbing the liquid-gas interface. They also reduce the interfacial tension between oil and water by absorbing the liquid-liquid interface. Wetting agents increase the spreading and penetrating properties of a liquid by lowering its surface tension. Wetting agent stretches the sponge and decreases the tendency of molecules to bond together, which allow the liquid to spread more easily across any solid surface. The emulgator consists of nonpolar groups and polar groups. This is called amphiphilic. The mechanism of the emulgator is through a nonpolar group that bonds to a nonpolar compound. While the polar group will bond water so that it will form globules that dissolve both phases liquid. This is what makes the liquid and oil phases as if they are mixed homogeneously. The size of hydrophilic and lipophilic parts affect emulsifications. If a capillary tube is placed vertically into a liquid, capillary action will raise or suppress the liquid inside the tube depending on the combination of substance. Prepare a bowl filled with water and then one paper clip. Place the paper clips in vertical position and see what happens with paper clip. The paper clip is sink because it is made of material that has a density greater than the density of water. Now, place the paper clip in horizontal position. In this experiment, we can see the high surface tension helps the paper clips with much higher density to float on the water. That's why the paper clip doesn't sink on the water. Prepare water in a bowl and talc powder. Pour the talc powder on the water and then stir it gently with small straw and see what happened with talc powder. So in this experiment, the talc powder doesn't sink because there is no water agents or surfactant that can decrease surface tension, and maybe it's because the several talc powder contains like fatty ingredients. That's why the talc powder doesn't sink on the water. Prepare water, soap, straw, and paper clip, and pour the soap dish into the water. Mix it with small straw. Do not foam. And then put the paper clip in horizontal position. So in this experiment, the paper clip is sink because there's surfactant that can break the surface tension, even the paper clip put in the horizontal position. And now put the talc powder in mixture of water and soap dish. Mix it well and see what happened with the talc powder. As we can see, the powder dissolved into the water because there is soap that contains surfactants that can reduce or break surface tension. That's why the talc powder is dissolved into the water. Prepare water, cooking oil, and straw. Pour cooking oil into the water and then stir with small straw. As you can see, the oil and water doesn't mix together. It's because liquid water is held together by hydrogen bonds. Oils and fats don't have any polar parts, and so for them to dissolve in water, they would have to break some of the water hydrogen bonds. So the oil is forced to stay separate from the water. Now prepare some dish soap. Pour dish soap into the mixture of oil and water. And then mix it well with a small straw. As we can see in this experiment, oil and soap is mixed as well. It's because the soap role as an emulsifier. Prepare water in the cup and then take the water with a small straw. Mark the meniscus with marker. Take a mixture of water and soap with straw and mark the meniscus with marker. Put a mixture of water and oil with straw and mark the meniscus with marker. When capillary tube is put into the fluids that wets the wall, the liquid will rise because of surface tension. In this experiment, we have a water sample, water plus soap, and water plus oil sample. As we can see, the mark of water plus soap is more higher than water and water plus oil mixture. Why water and soap mixture much higher than another? It's because of the soap. The soap contains a surfactant which can break a surface tension in the water, so that the incoming fluid will be higher than another fluids. Thank you guys for watching this video, and I hope you guys learned about something from this video, and see you on the next experiment. Bye bye, keep learning. Assalamualaikum warahmatullahi wabarakatuh.